Okay, so I'm back to work on making this bracket. I've lost my assistant. He's got better things to do. Not really, but I want to get this done and he doesn't want to do it with me right now, so I'm not going to force him. So I'm satisfied with the way this looks. It's good enough. We don't want to make this too fancy of a thing here. I'm just going to, while I still have it in the vise, I think I'll deburr the edges, and then we'll take it out of the vise, we'll bring it out to the boat, and I'll hold it up and transfer some lines to locate the bolt holes. What? So I measured the distance from the outside edge of the two existing bolts, and then I measured the distance from the inside of the outside edges of the two existing holes, and the difference between the two is 0.876, which off the top of my head I don't remember what fraction that is, but 0.875 is a fraction. So what I'm thinking is if I turn these into elongated holes and I just increase them, I move this outer edge basically out and in effect create an oval hole here by half the distance of this. I should be able to put this bracket on there 438 thousandths. I should be able to put this bracket on there on the existing bolts using these two bolt holes, and they'll just be slotted, that's all. Which I don't care about that. Alright, so I'm going to elongate these holes by exactly enough to allow me to, maybe, you know what, I'll go a little extra to allow me to use those existing studs. So what my setup is I basically just put this in the vise on a couple of parallels to keep it up off the bottom of the vise. I didn't actually have to do that now that I have it overhang. So I could get really fancy here, and I could put a center finder in here and indicate and line up exactly over the center of this existing hole. I'm not going to get that fancy. I just threw in a 2-flute end mill, same size as the hole that's already existing, and I basically just kept doing this and adjusting slowly the X and Y axis until this goes into that hole without touching. That's close enough for my purposes. Alright, so what happened was actually I already just backed it up, but the flutes of the cutter here, the aluminum is kind of, because it's soft, and the properties of the aluminum caused it to just build up and collect and turn into almost like a plug of aluminum, deformed aluminum that was just clogging that and had basically stopped this from cutting. So then the thing was kind of like plowing the metal ahead, and I didn't get a very good clean cut hole. So what I just did was I used a pick tool to pick out the aluminum that was stuck in there, 2 big chunks because it's a 2 flute, and went back and I just did basically a plunge operation, moved the table a little bit, plunged again, moved it, and just cleaned that hole up. So, lesson learned there when working with aluminum. So I think what I'm going to do is, when I come down this end here, I'm just going to, instead of trying to take a full depth cut, what I'm going to do is I'm just going to, same thing, I'm going to line it up so that I'm right in the hole. Then I'll move the table over a little bit, do a plunge, move it over a little more, do a plunge, and just do it that way. Yeah, I must have miscalculated on, I didn't count the proper revolutions or something, because I can clearly see this slot is smaller than that slot. Alright, so I just tried the fit, and those holes are nowhere near long enough yet, so I'm a victim of bad math, my own bad math. But I figure while I'm at it, I gotta get this bolt to stick out further. Either this bolt is much shorter than the other one, which I kind of doubt, or this bolt is pushed in for some reason. So the only way I'm going to find out is to open up and get underneath this transom here, this thing. Now it turns out there is a little trap door right there. Alright, so I could see the head of the bolt that's all the way in, that's fine, and this one is, yeah, sure enough, it's backed way out. And that has caused the silicone, that right there is not a snake, that is the remnants of the silicone sealant that was on that washer on that bolt head. You know, if I put a punch on there and I give it a whack, it'll pop that bolt right out, but I know what's going to happen. The bolt's going to go flying, drop down into the transom somewhere where I can't reach it, which will not be good. Alright, Aiden, show everybody what you made in school this week. So Aiden's going to Voc-Tech school, and he's in what they call the exploratory program. It's freshman year, so the first half of freshman year he gets to go through, how many shops? 6. He goes through 6 shops that he chose out of all the shops there.
Out of 22.
Out of 22 shops, and then after the six shops are gone through, he then makes a decision on what shop he wants to go to. And then if for some reason he can't get into that shop, he goes to the second one on his list, and so on and so on. So first week in shop, he was in metal fabrication.
Yeah.
And he made, what'd you make? You made a dustpan?
2 dustpans.
2 dustpans.
1 tool holder.
A tool holder. A little tray, a tote tray.
Yeah.
Yeah, little tool tray. And then you made that little, in the foundry, you made that little wrought iron keychain thing, right?
Oh yeah.
Yeah.
In the forge.
Right, in the forge, okay. And then, what did I say, foundry? Yeah, I meant forge. All right, and then this week you were in
A machine shop.
Machine shop, which they now call,
Machine shop.
I thought they call it machining technology or something like that.
Machine
no?
shop.
Machine shop, okay. And one of the projects you made in machine shop was a punch. So you did lathe work, right?
Yeah.
And then you did knurling, turning, then you turned a taper, and then you heat treated it, right?
Yeah.
Hardened it, and that's your punch. So figured this is his perfect opportunity to put his punch to work. He's going to help me get this bolt out. All right, so wait, don't do anything yet. So yeah, you see what I'm doing, right?
Yeah.
Reason why I stopped is because I got to stick my arm down in there and hold on to the bolt, because if you just hit that, it's going to fall down and drop down inside the transom, and with the motor in the way, it's almost impossible to get my arms way down there. Plus, I don't really feel like reaching way down there and seeing what lives down there. Hold on. Wait till I get my hand on it. All right, go ahead. Okay, so this is what that looks like. See all the corrosion on there?
Yeah.
All right. So although the other one is all the way in, I'm going to take the other one out, because as long as I got these out, I'm going to make some gaskets to go inside here. Very good. And it looks like you heat treated it correctly.
Yeah. He gave it a giant whack when he was testing it.
Yeah. You did good. You done good. Now tell everybody on my videos there how you have no interest in going to machine shop.
It's my third choice.
That the more that I wish you could go there, the less you want it. So actually, I don't want you to go to machine shop anymore. I'm going to use reverse psychology on you. I really don't like the idea of you going to machine shop.
Let me do it.
Yeah, don't worry about it. Leave it on there for now.
I'm stronger than you.
That's fine. Leave it on there. Stronger smelling.
You mean smell good?
Oh, Jesus, that scared me. Mommy's watering her garden. I thought there was a snake over there or something. All right. Yeah, the missus just telling me to put some bug spray on because the mosquitoes are out. And where we've got here in Massachusetts now, we've got this EEE virus thing that's really bad, killing some people, unfortunately. Can't even go outside anymore without something getting you. All right. 10.405, right? And what do I actually have here? At 10.230. So if I subtract 10.230, I get 0.175. So I need to make this distance from this outside edge of this hole to this outside edge of this hole 0.175 inches longer. So if I divide that by 2 and I add that much to each side, that should do it. But was one of these sides a little longer than the other? I don't know. Do I really care? Probably not. The difference from here to this edge and here to this edge is only 10 thousandths, so I'm not going to worry about that. So I'm going to take the 0.175, I'm going to round it up to 200 thousandths. I'm going to make this slot 100 thousandths longer in this direction, and this slot 100 thousandths longer in this direction, and that should do it. Oh, Aiden wanted to show everybody his projects from metal fabrication. So that's the dustpan, right?
Yeah.
So that's made out of what, galvanized
Yeah.
steel? Yeah. And that's the tote tray. What'd you
Yeah.
do, sit on it? It wasn't bent like that before, was it?
Nope.
Oh.
It was in our house.
So it should have been safe. Oh yeah, and this is the keychain. This is the wrought iron
Took 5 hours to make.
keychain. Took 5 hours to make this. We already decided that we'll probably modify this at some point, right?
Yeah.
Cut this extra long piece off so that we can actually have a keychain that can go in your pocket without stabbing you in the leg. All right, pretty good though, right?
Yeah.
So all I did was lowered the cutter down in the hole and slowly moved the table over in that direction until it just touched off and just took like a little skim cut. And then I zeroed my dial here, so now I'm gonna elongate this hole by 100 thousandths, and I'm gonna do it in 20,000 steps. All right, now we're going to move it down the other end and do the same thing. That should do it. The other nice thing about taking these bolts out is now I can stick them in from this side for testing the alignment. I don't like this space in here. So what I want to do is I want to mill slots on the back side of this bracket that will allow this to basically be recessed in there. So I need to determine three things. I need to determine the depth that I need this slot to be. Okay, which ideally is going to be about the thickness of this piece behind here. And then I need to determine the position of the slot, left to right here, right? And last, I need to determine the width of the slot. Okay, now the width of the slot, I can play with that, I can fudge that a little bit, which will help me be able to not have to be super spot on with the position. But I'm just gonna, I'm gonna stick a square right on here, combination square, and I'm gonna scribe a line right there. And then we'll take a dimension of that bracket right there, and we'll see what that's close to dimensionally and just increase it a little bit. And then as far as the depth goes, I can also, because this isn't perfectly flat, the back of this bracket, what I can do is I can take a measurement from this surface to the transom and then subtract this width, the thickness of this, to get that dimension of how deep I want that slot. This small steric combination square is going to be the perfect tool for this job. Got the motor turned in that direction, so I'm going to do this side first. I'm just going to loosen the square. I'm going to bring this down here like this, tighten it back up. Now if I put it just like this and I scribe a line there, that pocket's going to be kind of tight to that. I want some clearance there, a little bit of a fudge factor if you will. So I'm going to move this out just a little bit. So I'm using a carbide point scriber. Also, that's giving me this depth of the pocket that I was talking about. And scribe that line. I'll keep this set and I'll take this measurement with me down to the basement. So I got one more measurement I want to take, which is the width of that slot. How wide do I need that slot to be? Well, I need it to be at least as wide as the bracket is here. I moved this line over a little bit for clearance, so I got to take that into account. What if I did 1¼ inch, 1.250? That seems a little excessive. I did 1 1/8, which is 1.125. That's not too bad. I think I could live with that. All right. So I know that I set this square to the depth of the to the distance from the face of my bracket to the transom. So if I subtract the thickness of the bracket from this total dimension right here then what's left over is the thickness of the bracket. Also, what would be the depth of the pocket that I'm trying to make. So if I take my calipers and I just use the depth gauge on the calipers like so, I get 1.6640, but I really don't care about that dimension. All I want really is, I'm going to zero the origin, and I'm going to, I already measured the thickness of the bracket. The bracket is 20 thousandths over 1 inch in thickness. So now if I just go back to 20 thousandths over 1 inch, close enough, and I'm going to zero my origin again. And now if I close this, I get 645 thousandths. So that's how deep I want to make that. So I got this set on parallels, so it's raised up far enough so I should be able to cut this to the depth that I want without hitting the jaws on the vise. So I've got this where it was just touching off on the top here, and I've brought it to the rear. And now what I'm going to do is I'm going to zero the dial on my knee. So I'm just going to set this to 0. And now I'm going to bring it up 645 thou. Alright, so I had to change my setup. I had taller parallels in there, but with the tall parallels in there, when I tried to bring this down to 645 thousandths, before I could get there, the end mill was hitting the jaws. So I didn't obviously want to do that, so I ended up resetting it so that my piece now overhangs. So the part that's actually going to be where the cutter is going to be going through over here is no longer directly being clamped by the jaws. It's hanging out, so it's not going to be as rigid. So for that reason, I put in my short parallels, and that way I'm clamping almost the full length. I actually could have even just taken the parallels out and clamped this all the way down in, because I'm working off to the side here. So now I dropped this down to 645 thousandths, but looking at the back here, it's obvious to me now, and should have been obvious right off the bat, if this is only just a hair over 1 inch thick, I mean 20 thousandths over 1 inch thick, 645 is more than half the thickness of this is going to be plowed out, which is going to leave a thin part over here, thinner than I really like at this point. So I'm rethinking my whole idea of notching this. At the very least, I don't think I want to notch it to the full depth I originally thought. I think what I'm going to do is I'm going to take out 300 thousandths, and I'm going to see how the fit, how it fits, and go from there. Well, I just finished cutting the second slot. Should be the same depth as the first slot. The first slot, the finish on the bottom's not too good. I got an area here, you can feel a high spot. I was having a problem where The again, the aluminum having such a plastic quality to it loads up the cutter, and when I was trying to go plow through too quickly, what would happen is that I think the cutter was loading up and it was actually starting to try and ride up on top of the piece and literally flexing this piece enough to actually change the depth of cut a little bit. So by not taking as deep a cut and by slowing down my feed rate, I think I solved that problem. This finish came out pretty nice. I'm happy with that. Yeah, something happened here. As I suspected when I milled this side, something really bad happened. I'm not sure whether or not the cutter actually slipped in the collet because of the upward force being exerted on it as the chips collected and built up underneath here, or what. But basically what happened here is I can measure this. This is almost spot on 1/4 of an inch with this quick check gauge, and front to back it's pretty good. Whereas on this side, the back is about 1/4 of an inch, or a shade over maybe. But up here in the front, it's like a 32nd of an inch, maybe even more, deeper. Well, for the job that it's going to be doing, that's not really critical, but it is kind of, it is kind of disappointing. But yeah, trying to decide how much deeper I want to make these pockets. It could be a little wider too. Alright, so I've decided that I'm going to widen the slots, and since I'm not that far from 1.25 inches, I decided to switch out to a 4-flute 1.25 inch end mill, so that I can make the entire width of the slot in one pass. And the other thing I did was, of course, in order to use the 1.25 inch end mill, I had to switch out to my big end mill holder. Okay, and what I've decided I'm going to do is I've brought the end mill down to almost the top of the vise right here. So what that's going to let me do is I'm going to be able to make this pass, cut this slot, then bring the end mill out to here, traverse across, and cut this slot without touching any of my height adjustments. So I should end up with two slots the same exact depth and width. The other thing I did was I pulled out my machinist handbook pocket guide, and I checked, and for an 1.25 inch end mill in aluminum, I should be able to easily get by with 600 RPMs or higher. So I'm just going to run it at 600 RPMs, and that's quite a bit faster than what I was running those other cuts at. So that's probably part of my problem, was I was running that end mill too slow. Especially since the other end mill was smaller in diameter, it definitely should have been even higher RPM than this. And 600 is quite a bit faster than what I was running it at. I'm not even sure what RPMs I was running at before, but I had the control up here on the Wells Index down to 400, but that wasn't 400 RPM because I wasn't running the VFD at the full 60 cycles or 60 hertz. So the motor was actually running slower, so who knows what I was doing there. The only bad part about this is it's going to throw chips like a madman. Here goes nothing. That wasn't pretty. Well, the bottom of that slot looks rough as heck. So if I had to venture a guess, I'd say either, I mean, I've got these really, really fine little needle-like chips. So I think my feed rate is too slow for that RPM. Because I'm manually feeding it, of course. And I'm getting a ton of chatter. Could also have a, I thought that end mill looked pretty good, but maybe it's duller than I thought. Well, anyways. So now the plan is, see if I can run it back, run it over, cut that side. Now I know I didn't touch the height of my setup, but I don't want to find out that something changed that I wasn't aware of. I mean, this shouldn't be able to come out of here because it's not a collet. It's locked in by a weld-on shank, but I don't want to cut my vise by accident. No, all right, clearance is still good, so that's, so far that looks okay. And if I had kept it running and that had slipped down and it hit this and I had ruined the, made a mark on the vise, I really would have regretted it. All right, I'm going to see if I can't crank the handle faster and increase the feed rate on this pass. Well, that was better. But that's because this slot was deeper already, I think. So I just took a smaller depth of cut on this side. But now I should be able to measure these and the depth should match.